Open API documentation. Just to check it out, iterable. Go to Java base module. In the Java base module, go to java.lang package. Java.lang package. You can see iterable. In the base module, in the java.lang package, iterable. Iterable interface. All noun subinterfaces. Under all subinterfaces, you can see collection. Please follow collection from the iterable. Everybody. From the iterable, follow the collection. All known subinterfaces for the collection. You can see list interface. List interface. Follow the same. Check it out, all known implementing classes. You can see array list. Follow the same. Let us repeat once again. In the API documentation, go to the docs and API. Please follow me. Go to the docs and API. Inside a docs API, in the API documentation, docs folder, API folder, inside a API folder, open with Google Chrome. Index, open index. Inside index there is a Java base, go inside. Inside a Java base there is a java.lang, go inside. Inside a java.lang, search for iterable. Inside a java.lang there is a iterable, click on it. All known subinterfaces. You can see collection. Collection is a subinterface to the iterable. From the collection you can see list. Click on the list. From the list you can see array list. Let us go back. Array list is a sub-interface to the list. All super interfaces, come on, all implemented interface as a list. List is a sub-interface to collection. Collection is a sub-interface to iterable. Collection, iterable. This order everybody should know. So whatever we observed, please write in the diagram. Represent in the diagram, everybody. Iterable, iterable is an interface then collection. Collection also an interface. Then list. It is also an interface. Then array list. This is a class. Array list is a class. List is an interface. Implements dotted line. Collection to the list, both are interfaces. Extends. Extends means solid line. Iterable and collection both are interfaces. Extends, that is solid line. So here, iterable, collection, collection, list. These three are the interfaces. Array list is a class. Please go through this completely. Guys, iterable is a interface. Collection also interface. List also interface. Three interfaces in this diagram. Iterable, collection, list. These three are the interfaces. Iterable is an interface. Collection also interface. List also an interface. Array list is a class. Array list is a class. Guys, here collection is an interface, but we have already seen collections. For sorting purpose, we have seen collections. If you consider collections, it is a class. Collections. In this diagram, it is not there. Already we have used collections. It is a class. Collection is an interface. One more observation. iterable. It is a part of java.lang package. This is there in the java.lang package. Remaining all are in java.util package. The entire collection API available in the java.util package, but iterable, it is a general interface. It is available in the java.lang package. Iterable java.lang package. Iterable is in java.lang package, remaining all other members from the collection API. Remaining all the members from the collection API available in the java.util package. Java.util package. Iterable java.lang package, remaining all are in java.util from the collection API. Collection extending to iterable. List also, queue set also extending to collection. Collection is a super interface to list, queue and set. List, queue and set. Map is separate, all are interfaces here. Extending. The total collection API can be divided into 4 parts. The whole collection API can be divided into 4 parts. 4 streams are available. 4 streams. One is a list, second one is a queue, third one is a set. These first 3 are collection type. There is one more stream, that is map. Map is not a collection type, but it is a part of the collection framework. Map is not a collection type. Map is not a collection type, but it is a part of the collection framework. List, queue, set, then map. In case of list, everybody, in case of list, index is providing internally. In case of list, index is providing, that is why it maintains the order. List is mainly for order purpose. It maintains the order. List internally using index numbers. List internally using index numbers. It maintains the order. It maintains the order. Come to the queue. You know already. First in, first out. Queue maintains first in, first out. First in, first out. Then set. It is for uniqueness purpose. Set won't allow duplicates, only unique elements it will be allowing. Set won't allow duplicates, only unique elements it will be allowing. Only unique elements it will be allowing. It won't allow duplicates. It allows only unique elements. Set. Set allows only unique, no duplicates. Come to the map. Map is a key value pair. Key element or key value pair. Mapping element with a key. Mapping value with a key. Every element should be mapped with a key. Every element should be mapped with a key. Every element is mapping with a key. Every element is mapping with a key. Key value pair is a map. Key value pair. We cannot store the element directly in the map. You have to assign with a key while storing. Key value pair is a map. Key value pair is a map. So totally 4 streams are there. List, queue, set and map. So please observe once again, go to the documentation. Under iterable, click on collection. Under iterable, click on collection. You can see by using collection, list is derived. By using collection, queue is derived. By using collection, set also derived. Observe everybody. I'll increase the font size. By using collection interface, list, you can see the set. You can also see the queue. From a collection interface, list is derived, queue is derived, set is derived. List, queue and set. Now, everybody, there is no map interface here. Map is a 1/4 of the collections, but map is not a type of collection interface. Everybody, enhanced for loop, that is for each loop, enhanced loop, that is for each loop, enhanced loop, that is for each loop, for each loop, enhanced loop, that is for each loop, for each loop. For each loop, enhanced loop. For each loop, enhanced loop. For each loop, allowed to use only for arrays and collection. Arrays and collection. Collection means list, queue and set, not the map. We cannot use for each loop for the map. We cannot use for each loop to the map. We cannot use for each loop to the map. For each loop, it is only for arrays and collection type. Arrays and collection. Collection is a list, queue and set, not a map, but map also a part of the collection framework. Map also a part of the collection framework. Everybody, now come to the list. Click on the list. Under list, you can see all known implementing classes. All known implementing classes under list. You can see linked list class, array list class, vector class, even stack class, everybody. There is a linked list class, there is a array list class, also vector class, even stack also. So let's click on vector. Vector is a superclass to stack. Vector is a superclass to stack. Let us analyze completely, everybody. You know the list. So let me mention iterable. From the iterable collection, it's not a collections, collection. Collection. From the collection, there are three interfaces. I am representing only list. All these three are the interfaces extents. All three are the interfaces extents. Then you can go for array list. After array list, you can go for vector. So this vector is superclass to stack. Vector is a superclass to stack. one more class, linked list. These three are the classes implements. List is a interface, vector is a class. List is a interface, vector is a class, linked list also a class, stack is a class, vector is a class to class extends. You know already iterable. It is a part of java.lang package. Collection. It is an interface from the util package. List. It is also an interface from the util package. First three are interfaces. First three are interfaces. First three are interfaces. Last four are classes. First three are interfaces. These are the interfaces. Interfaces. Then the last four are the classes. These are the classes. We have seen almost all the operations by choosing array list. Everybody. We have seen how to add, how to read, how to remove, how we can able to search, sort. Main operation is a sort. Remaining all are self-explanatory. By seeing the method name itself, you can easily come to know what that method is doing. But sorting having lot of information, you should know clearly comparable, comparator, comparable, comparator. So now here, whatever operations you have seen in the array list, all operations available in the vector, linked list and even stack also. No need of experimenting all these operations once again through vector, once again through linked list, once again through stack. You got to know what are the different ways available to add, what are the different ways available to read, modify, update update, search, and also sorting. So all those things you already seen from the array list. Now those operations you can get through vector, you can get through stack, you can also get through linked list. Vector, stack, linked list. So no need of experimenting separately. Still if you wanted you can do. But now mainly, why these 4 classes are there under list? Why can't only one class? So already we have seen significance of list. What is the significance of list? Just now I told. Maintaining the order. Internally, it is using index number. It maintains the order. It maintains the order, maintaining the order internally. Ordering. List significance is order. In whichever order you are adding, in the same order you can read. Order of addition is preserving. Order of addition is preserving. Order of addition is preserving. In whichever order you are adding, in the same order you can read. In whichever order you are adding, in the same order you can read. Order of addition is preserving. There are 4 classes under list. Some more classes also there, but these 4 classes are mainly considerable under list tree. So why 4 classes introduced? Why not only array list? Even though all are for maintaining the order. So here, each class having its own specialization. Even though all operations are almost common, every class having its own specialization. Based on your requirement, you can pick which class you wanted. All these 4 classes maintaining the order of addition. In whichever order you are adding, in the same order you can read. Every class having one additional specialization also. So please observe. Array list internally using array. Array list internally using array to maintain the elements. To maintain the elements. Array list internally using array only. I'll show you how array list is using array internally. Please observe the speciality of the array list class. Array list internally using array. Array list internally using array to store the elements. Internally, it is using array to store the elements. Array list internally using array. While using array, we will be getting one advantage. Reading operation will be very efficient. Why? Because array uses memory locations, continuous locations. Come on, in the memory, array will be using continuous locations. Reading operation will be very simple. Read the current element, go to the immediate next location in the memory. Read that one. Go to the immediate next location in the memory. Read that one. So whichever containers using array internally, those containers will give ultimate performance in case of reading. In case of reading, you will be getting ultimate performance if container using array. Array list is a container which is using array internally. In the collection framework, whichever collection classes using array internally, those gives ultimate performance in the reading. While in the array, memory locations will be continuous locations. Array will be using continuous locations. So let us consider one element is stored in the memory, in the array. Next element of the array stored in the next location only in the memory. So going to the next location is very simple. Going to the next location is very simple. That is why array list gives ultimate performance in case of reading. Reading is also called as a random access. Random access is a efficient in the array list. Array list gives a ultimate performance in the random access. Array list gives ultimate performance in the random access, that is reading. In your requirement, more and more reading operations, frequently accessing elements from the container, then choose that container as an array list. Array list gives ultimate performance in case of reading. So, in your requirement, if elements keep on reading frequently, very frequently, keep on reading more and more reading operations, then go for array list. Array list. Because of using array internally, array uses continuous increasing memory locations to store the elements. You can read element by element very easily. At the same time, there is a limitation in case of array list. If you want to insert any element in the middle, any element in the middle, the current element should move to the right side. That right side element should move to the next right. Likewise, every element should move to the right shift by 1. Insert operations, remove operations, not very efficient in the array list, but possible. Possibility is there. Internally, more operations are happening. For one insert, lot of shifts are happening. Shift by 1, right shift by 1. If you want to insert one element in the middle, right to that every element is moving to the right shift by 1? Yes or no? If you are inserting any element in the middle, wherever you are inserting, that element should move to the right side. Whatever element was there in the right side, that should move to the right side. Likewise, every element is keep moving to the right side. Lot of operations. Insert is not efficient but possible. Insert is not efficient but possible. Similarly, if you want to remove one element from the array list, I want to remove one element. So whichever element you are removing, that element should be occupied by whichever element was there in the right side. So something like a left shift by 1. Come on guys. If you want to remove one element in the middle, wherever it is there, right to that whichever element is there, that is moving to the left side. So please observe, I'll represent it diagrammatically. Let us consider this is an array. Let me make bigger one. Yeah. Assume these are the elements. If I want to remove an element from here, so we need to move this element to here. Then this element will be removed. So now this element should move to here. While removing left shift by 1, while inserting right shift by 1, while inserting right shift by 1, while removing left shift by 1. Yes or no? Left shift by 1, right shift by 1. So in the array list, reading is very efficient. Insert and remove, not efficient, but possibility is there. Possibility is there, not efficient. So don't look for array list. If more frequent insertions, frequent removals are there, frequent insertions, frequent removals are there, then don't look for array list. Then come to the vector class. Vector class completely synchronized. Every method of vector class, every method of vector class is synchronized. Every method of vector class is synchronized. Every method of vector class is synchronized. Synchronized. Already you know synchronization. All the methods of vector, all the methods of vector synchronized. Vector you can use in the multi-threaded environment. In the multi-threaded environment, you can use vector. Vector specialization is multi-threaded environment. Multi-threaded environment. Multi-threaded environment. Vector specialization, multi-threaded environment. You can use vector in case of multiple threads are trying to store the elements in a container, read the elements from a container, modifying the elements from a container. Vector. Multi-threaded environment, vector. But here, the complete synchronized, not at all recommended because of the performance issue. The class which contains the whole synchronized is not very recommended to use even in the multi-threaded environment. Even though it is a multi-threaded environment, class with the whole synchronized is not very recommended with respect to performance. You will be getting a less performance. So calling vector as a legacy class, nowadays we are not using vector because of it is the whole synchronized, not at all recommended to use vector, gives a less performance. It is called as a legacy class. Legacy class means it is the older way, not very recommended, the whole implementation is a older way. The entire method got synchronized in the vector. You can use in the multi-threaded environment. You will be getting more and more accuracy in case of data management. At the same time, because of every method is synchronized, performance will be reducing. Same stack also, vector and stack both comes under legacy classes, not using nowadays. There is a way to address with multi-threaded environment. Vector mainly introduced for multi-threaded environment because of the whole synchronization gives a less performance, but ultimate accuracy you will be getting. Ultimate accuracy you will be getting, but less performance. Accuracy wise 100%, performance wise decreasing because of every method is a synchronized. There is another way to achieve the same in the multi-threaded environment. So we don't want to go for everything synchronized even though multi-threaded environment. So whichever methods doing some updatable operations, those only should be synchronized, not all. That is why some people provided another way. So that other way I'll explain you later. So as of now, you can think like vector is introduced for multi-threaded environment. It is completely synchronized. So it is absolutely possible, absolutely advisable to use in the multi-threaded environment. But in the multi-threaded environment, while using vector, as it is fully synchronized, you will be getting a less performance. So that is why nowadays vector is not using. Even stack also say not using. In place of these two, we have other ways. Array list itself we can use in the multi-threaded environment by synchronizing. How we can synchronize array list? There are two ways that you will come to know later. See, if you want to use array list in the multi-threaded environment, we can make it as a synchronize. How we can make it, that you will come to know later. So here vector and stack highly recommended to use only in the multi-threaded environment, but unfortunately 100% synchronized, giving a less performance. Please observe, vector is fully synchronized. You can use vector in the multi-threaded environment. The speciality of the vector is synchronized. The speciality of the array list is internally it is using array. It gives a ultimate performance in the random access reading operations. Now let's move to the linked list. You know already linked list. Lot of examples you already practiced in the linked list. Linked list, it is not using array internally. Come on. It is using a linked list structure. You know very well, linked list structure. One object referring to another object. That second object referring to third object. Link is maintaining among the members. That is how multiple members are storing in the linked list. In the linked list, multiple members are storing through a link. First member linking to the second member. Second member linking to the third. Third is linking to the fourth. So linked list, not using array internally, it is using linked list structure. You know already linked list structure. First element pointing to the second element pointing to the third element pointing to the fourth element pointing to the fifth element. Linked list. What is the advantage while using linked list? It is not using array. If it is not using array, then it can have all the advantages wherever array was having a limitations. Array limitations can be addressed through linked list. So here, inserting any element in the middle, removing any element in the middle, Very easy compared to array. Yes or no? You have seen lot of examples in the linked list. In case of linked list, any element in the middle we can easily remove, we can easily insert. Let us consider. So consider this is a linked list. So let us consider I am representing some data. I want to remove 7. While removing 7, before 7, no link will be disturbing. After 7 also, no link will be disturbing. What you have to do, just to remove this link only, directly link from 5 to 3, then 7 is removed. Yes or no? Very easily removing. Let us consider I want to insert one element between 3 to 6. If I want to insert any element between 3 to 6, before 3 no disturbance, after 6 also no disturbance. Please observe, I want to insert one new element 8 between 3 to 6. Only this link will be collapsing. So let 3 is pointing to 8, 8 is pointing to 6. Understanding or not? This much easy, not possible in the arrays. Got it or not? So linked list is addressing limitations of array list. Linked list is addressing limitations of array list. In the linked list, there is one limitation. Come on, guys. In case of linked list, there is a limitation also. If you want to read all the elements, assume there are 1000 elements in the linked list. Reading elements one by one, one by one. So here, in the diagram, we mentioned first, then 5, then 7, then 3, then 6. In the memory, all these objects will be scattered. All these objects will be scattered in the memory, but there will be a link. Come on. Elements are not like a side by side. Scattered. There is a link. Through a link you can reach to next element, but it may be somewhere else in the memory. From there you can reach to another element. That also it will be somewhere else. So reading operation not efficient. It has to travel in the memory from one location to different location. It may not be nearer by. It's scattered. All elements is scattered. So something like everybody. So one element is here. One element is here. One element is here. One element is here. Let us consider this is referring to here. This is referring to here. This may be referring to here. This is scattered different locations. So random access is very inefficient. Random access not efficient. Reading operation is not efficient in the linked list. So based on your requirement, if it is multi-threaded, choose vector. If you have a more and more random access, choose array list. If you have a More and more insertions, removings, go for linked list. It's purely based on your requirement. Collection API, we are not developing any tasks. We need to take a decision based on the requirement, which class is highly recommended inside that class, which method is highly suitable to your task. Yes, sir. Highly suitable to your task. That is only we are learning in the collection API. We are not developing even a single task. Even sort also we did not develop. We only provided how to find out a difference between two objects. In the compare to method, we are finding out the difference between this and argument. In the compare method, we are finding out the difference between O1 and O2. The actual sort developed in the sort method. Come on. Actual addition already developed in the add method. Remove, get, size already available. Sort methods also already available. What we are providing, how our elements can be sorted. Logic already there. Evaluation only we have to provide. That evaluation is based on which attribute difference framework has to sort. That only we are mentioning in the compare to method and in the compare method. Sort. So in the collection API, we are not developing any task at all. We are identifying which is the best for our task. Understanding? So according to me, the simplest topic in entire core Java is a collection API. So here we are just walking through all the classes, all the interfaces, all the methods to make a decision which class is suitable in a particular requirement, which method is suitable in a particular requirement. So, please go through all these points, whatever points we have covered, everybody. Iterable collection list, array list, vector and linked list. Stack is much more legacy. Nowhere is using. Only in the lead code examples to solve some of the requirements using a stack. But generally in the real-time projects, we won't use stack. We won't use even vector also. We will be choosing some other techniques.